Okay, number 2. Next. Number 2, compute the buoyant unit weight. So what is the buoyant unit weight? That is also the submerged unit weight. So yun siya. So it is denoted as gamma prime. Or you can also see gamma B. Okay? So for this one, okay, so we have equations to choose here. So we have gamma prime is equals to gamma sat minus gamma water. So in order to solve this one, we need to solve first for the gamma sat. So for the gamma sat, we have gamma prime. We can also direct to the equation, no? Gamma sat first. So gamma sat equation, that is equivalent to the specific gravity plus the void ratio E multiplied by the unit weight of the water all over 1 plus E. No? So, and then we can also use the equation. We have gamma prime that is equivalent to, so that is equivalent to GS minus 1 times unit weight of the water over 1 plus E. Okay, so that's the equation. So we can use either. We can also use gamma sat, or you may just say gamma prime. If you're going to use this one, is equals to, we have specific gravity plus E times unit weight of the water over 1 plus E minus gamma water. You can just use this one, but that is also, this one is also from that one, no? So you can use any of the equation. Depends on you, no? Depends on you. So let's try to use this one. So gamma prime is equals to specific gravity minus 1 times unit weight of the water all over 1 plus E. So we have gamma prime is equals to, our GS is 2.74 minus 1 times 9.81 all over 1 plus 0.52. So calculate this one. We have, so we have 11.22 or 11.23 kilonewton per cubic meter. So that's our buoyant unit weight. Okay, next, number 3. So we have the buoyant unit weight here, additional. So we have gamma prime is equals to 11.23 kilonewton. So number 3, the question here is, compute the weight of water in kilonewton to be added per cubic meter of soil for 90% degree of saturation. So, what are we going to compute in here? So, the question somehow is tricky, no? You may think that what we're going to compute is the weight of the water. So, literally, we can imagine the weight that is in kilograms, no, or in kilonewton. But there is an additional here, that weight of water in kilonewton per cubic meter. So therefore, what is asking here is somehow a unit weight. And then there is an additional given, that is degree of saturation, that is equivalent to 90% degree of saturation. So how to solve this one? So when what's the tip here, no? Take a look. There is a degree of saturation which is 90%. Therefore, what type of, or what condition of unit weight is asked? So we have 3 conditions. So we have the dry unit weight, we have the moist unit weight, and we have the saturated unit weight, and we have also the buoyant unit weight. So think of it, no? What is asked is a unit weight. So we're going to solve, since according to the problem it's kilonewton per cubic meter. So think of the unit. So the unit is already given. Okay, so we can say that is a unit weight. So let's try to take a look what are the equation. So we have gamma moist, and we have already many given values here. So we have an equation for the gamma moist. Okay, so the equation here to use is that we have the equation GS, or specific gravity, plus SE times the unit weight of the water over 1 plus E. Okay, so let's substitute the values. So we have gamma moist. So we have our GS, that is 2.74, plus we have the degree of saturation in terms of decimal place. So this is 0.90 times our E, that is 0.52, multiplied by 9.81 yan, okay? Divided by 1 plus 0.52. So let's calculate this one. Okay, so the value calculated is 20.70 kilonewton per cubic meter. Okay, so this value, take note, this is not yet the answer. The question is weight of water. So we are only pertaining to the water that is additional, or that is added when the degree of saturation is at 90%. So therefore, this is the moist unit weight at 90%. And let's go back to the given. We have the moist unit weight that is 20.6. Okay, so to go to the answer to what is asked in the problem, so we're going to solve the difference between the two moist unit weight. So we have the weight of the water. This is equivalent to the value here at 90%, that is 20.7 minus 20.60. This is the given. So we do not know yet what's the degree of saturation of this one. However, we can compute. So we have the weight of the water added. So this is added for a 90% degree of saturation. So we have only 0.10 kilonewton per cubic meter. So this is the water added. Okay? We can also find out what's the degree of saturation for 20.60. So you can use the equation again, gamma equals to GS plus SE times unit weight of the water over 1 plus E. So try on your own. Try to solve for the S. Given this one, that is 20.6, and then you have already the other given, and you're going to solve for the S. So you can get the value of the degree of saturation for 20.6, that is around more than 80%. So that's it for problem number 2.